there, here we are with another question from our hashing series. The problem is 349th question from our LeetCode, which is interaction of two arrays. The problem says we are given with two integer arrays, num1 and num2, written an array of their intersection. Each element in the result must be unique and you may return the result in any order. The first example says that we are given with two number arrays. One is nums, and these are the elements, and another is num2, and these are the elements. So, as it's visible, we have two elements in common in both of the array, that is 2 and 2. But we are supposed to return a unique set of results. So, the answer becomes to be only 2. Of course, as the series suggests, we will be going with HashSet because HashSet is the best when it comes to unique elements. Before we start coding, let's visually analyze the solution, analyze the problem. So step 1 is store nums1. We initially have to create a hash set called set1 to store the unique elements from nums1. Of course, when we traverse through the array and add the elements into set1, we'll remain with only unique elements. Then we need to traverse through nums2. We need to create another set, hash set. Let's name it as result set. And then we need to traverse through the second array. And we need to add the element into result set if and only if the element is present in the first set. So for every element, check is it present in set 1? If it's a yes, then add it to another set called result set. See, for example, 2 exist in both of the sets, both of the arrays. So result will contain 2 as the element. But in this case we have two element, right? It's present twice in our first array and the second array. But since we are using hash set, we need not worry about the duplicates. We get the unique elements at the end. And the last step is to convert the result into array. Now we have understood visually how to solve this problem. Let's start coding. This is the algorithm that we'll be following. First of all, we need to add every element from nums to set1. Let's do it first. We need to declare a hash set first. Let me name it as set1 is equal to new hash set. And then we need to traverse through num1. We can just do it as set1 dot add nums. Automatically it removes the duplicates. Sorry, it's num. And then we need to traverse through nums2. How do we do that? We do it this way. We'll name it as n again this time. Nums2. This does the job of traversing. And then if set1 contains the current element, then we need to add it to set result set. We need to declare the result set hash set result set is equal to new HashSet. Oh, we forgot to write this thing, integer. Now if set1 dot contains n, then we need to add that element into result set. Result set dot add, right? Okay. The next step in the algorithm is to convert the result set into integer array. For that, we'll have to declare an integer array, say result, res, new integer of size result set dot size. This is a function from HashSet which is used to calculate the size of the hash set. And then we will traverse through the result set int n result set, and then we will add that element. Oh, we need the index, we need to declare it as well. Int I is equal to 0, I plus plus. This is like incrementing. Once you declare one index spot with one element of result set, then it has to increment, right? Otherwise things will get overridden. C equal to n, and then you need to return the array that is res. We are done with the solution. Let's try running it against the test cases. Oh wow, now let's submit. Yes, finally our answer is submitted. Now let's talk about the complexity. So the time complexity is big O of n plus m. Here n and m indicates the number of array elements present in nums1 and nums2. So we traverse both the array once. So the time complexity becomes big O of n plus m. Now moving on to the space complexity, it's big O of n plus k. That's because n elements may be stored in set 1. K are the common elements between both the arrays. K is the elements that is present in result set. In worst case, if say all the elements that is present in our second array, that is nums2, is present in the first element, then the complexity, that's the space complexity, becomes big O of n plus m. That is same as the time complexity. Note over here, n and m. N may be the number of elements in nums1 and m is the number of elements in nums2. Thank you for watching this video.